In an elastic collision such as these, momentum is conserved and so is kinetic energy. In experiments, we can get close to elastic collision by putting strong magnets at the front and back of vehicles, like this. Going back to simulation, let's examine in more detail what happens. So for large masses m and the smaller one little m, as the collision occurs, momentum in this closed system is conserved. That is, the total momentum before and after are the same. Written algebraically, that is as you see, with u being the initial velocity and v being the final velocity. But we now have a second expression. If the collision is perfectly elastic, then kinetic energy is also conserved. So adding up the kinetic energy of both trucks before and comparing them to those after, they are the same. These two toy vehicles have been weighted so they have the same mass. When we run one into the other, the first one stops and the second picks up and goes off at the same speed as the first. This is a reasonably easy situation to analyse. There is a perfect transfer of kinetic energy, and therefore there is a perfect transfer of momentum. So as the second truck moves off, the first one stops. Here, the first truck has a much higher mass than the second. In each case, the first truck slows but doesn't stop, and the second truck moves off faster. In this last demonstration, the situation is reversed. The second, much more massive truck moves slowly and the first one rebounds. No matter that it rebounds, the principles are the same. Momentum and kinetic energy are conserved. Remember in doing a calculation that although kinetic energy is a scalar, so you simply have to add the energies together, momentum is a vector. So in this case, the momentum of the rebounding light truck has to be counted as negative. Calculations on elastic collisions can be rather heavy on algebra. A simple useful relationship can be extracted from the kinetic energy equation. I'm not going to show that proof here because it's a bit tedious and you're unlikely to need to know it. But the difference in the velocities of the two vehicles after the collision is exactly the same, but reversed, as the difference between the two velocities before the collision. I hope that's been useful. There are several other video tutorials on momentum on this playlist here. Thank you for watching.